this video, we will discuss some navigational terms, that is the basic navigational terms like latitude, longitude, DLAT, DLong or departure, and we will see some formulas which we will be using in our further calculations for navigation. For example, if we want to calculate the distance or course from one point on the earth to another point on the earth, so what will be the course, what will be the distance, these all things we will discuss in this lecture. If you are new to the channel, then subscribe the channel so that you will get notification of my videos as soon as I release it. We will start with the topic navigation terms. So navigation terms, we will study latitude, longitude, DLAT, DLong, departure, and we will see some formulas. Let's get started. So latitude. As we know, latitude of a place is the angle at the center of the earth or the arc of the meridian contained between the equator and the parallel of latitude passing through that place. This is the definition of a latitude which we need to write if anybody asks us, or if it is coming in the question that what is latitude. Generally, in some of the examinations, this question is asked that what is latitude, what is longitude, and what is DLAT, what is DLong, what is departure. So if you want to write anywhere, you have to write this definition. Latitude of a place is the angle at the center of the earth. So suppose this is the earth. Then we will draw the equator. So this is the equator. Equator, as we all know, that it is 0 degrees. Now we will draw a parallel line to this equator. So before we proceed, everything above equator is called north and everything below equator is called south. This is absolute basics. This we are studying since 6th standard from the school time, that everything above equator is north, everything below equator is south. And this is equator. That will be 0 degrees. Okay. And the lines parallel to the equator, those are called latitudes. So this line is called parallel of latitude, because as we know, latitudes are always in degrees. So this is like a parallel line which is parallel to equator. So we are saying it as parallel of latitude. And as we know, this is the center. This is C. C is the center of the earth. So what our definition is explaining, latitude of a place is the angle at the center of the earth, or the center of the earth, or the arc of the, this will be arc, this is or, sorry, center of the earth, or this is or the arc of the meridian contained between the equator and the parallel of latitude passing through that place. So this is parallel of latitude, this is equator, so it is the angle at the center of the earth. So at the center of the earth we will mark one angle. So this is center of the earth from here to here, this angle. So this angle is called latitude. Okay. And what else it is saying, or the arc of the meridian. So like these are called, these parallel lines to the equator are called parallel of latitude. In similar way, the longitudinal lines are called meridians. These longitudinal lines which are running from north to south, those are called meridians. So this is one meridian, this from parallel of latitude, this point, like we can mark it from A to B. So this is a arc of the meridian. It is arc of meridian. So again, we will read the definition. Latitude of a place is the angle at the center of the earth. So it is the angle at the center of the earth, or the arc of the meridian contained between the equator and the parallel of latitude. So once you will draw the diagram, you can write the definition by your own. So this is only the definition of the latitude. But to fix the position, we need latitude as well as longitude. Latitude is always named north or south. This I have told you earlier, that everything above equator is north and everything below equator is south. So suppose this is 30 degrees north latitude, and again, if we will draw a latitude here, it will be 30 degrees south latitude. So this we need to keep in mind. So I hope till here everything is clear. We will move forward to longitude. Now what is longitude? So again, we'll read the definition first. Longitude of a place is the angle at the pole or the shorter arc of the equator contained between the prime meridian and the meridian passing through that place. So longitude is what? Longitude is the angle at the pole. So which point is pole? Again, we will draw one sketch. So this is a earth. Again, we will draw an equator over here. So this is an equator. Now we will draw one longitudinal line also. This one. So this line we will say it as 0 degrees. So this 0 degrees is called as prime meridian. Prime meridian. This 0 degree is called equator. Now we know that there are also lines which are joining north and south points. So these lines are joining from north to south in this way, like an arc. So everything east, everything right of the prime meridian is called east, everything left of the prime meridian is called west. So this also we need to remember. Now what the definition is saying, longitude of a place is the angle at the pole or the shorter arc of the equator. So angle at the pole, so we can make out that angle at the pole, this is a pole, this is north pole, and this is the below one is south pole. So it is the angle at the pole or the shorter arc of the equator. So there are two arcs now. This is the shorter arc, this is shorter arc. But if we will go from this side and revolve around and come here, this is the longer arc. So that's why it is mentioned clearly that longitude of a place is the angle at the pole or the shorter arc of the equator contained between the prime meridian and the meridian passing through that place. So this definition is also clear. It is named east or west of prime meridian. Everything on the right of the prime meridian is east, everything on the left of the prime meridian is west. Now we will move forward to D-lat and D-long. So what is D-lat? D-lat is the angle at the center of the earth or the arc of the meridian contained between two parallel of latitudes passing through those places. So if the, again we will draw one sketch. Suppose this is the earth and we know this is the equator, and again this is parallel of latitude and this is also parallel of latitude. So suppose this is 0 degrees, this is 10 degrees, and this is 20 degrees. It will be north because it is above equator. So D-lat is the angle at the center of the earth or the arc of the meridian contained between two parallel of latitudes. So this is one parallel of latitude, this is second parallel of latitude, this is center of the earth. So this and one more we will draw from here to here. So this angle is called D-lat or this arc is called D-lat. Okay, this is what D-lat is and it is trying to explain. Now we will move forward to D-long. So what is D-long? Similar to D-lat, D-long is what? D-long is the angle at the pole or the arc of the equator contained between two meridians passing through that place. So again we will draw one sketch. Again this is the equator and this is prime meridian, and again we'll draw two more meridians like this. So it is the angle at the pole. So where is pole? This is pole. Suppose pole north, pole south. It is the angle at the pole. So this angle it is defining. Or the arc of the equator. Arc of the equator is here, contained between two meridians passing through that place. So this is one place, this is two place, meridian passing through two places. So this is called D-long, D-long, and this is D-long. Okay, now we will move forward and we'll see departure. So as we know from physics that there are two terms, that is distance and displacement. So distance is what? Like from point A to B. If you will go from point A to B like this is called distance. But if you will go straight, this is called displacement. The departure is similar to this thing. So what it is saying, the effective distance moved either east or west is called departure. This is the surface of the earth. And we will draw some parallel of latitude. This is another parallel of latitude, and this is one longitude, this is another longitude. This is, suppose this is point A and this is point B. So from point A to B it is going like this. Okay, this is distance from point A to B. So this is called distance. And what it is traveling from east west is called the departure. So if you travel from here to here, from A to B, this is called distance and this is called departure. This is the effective distance moved either east or west is called departure. So this we are using in our terrestrial navigation. So that's why this concept should be clear. So now moving forward to next, these are the formulas which we are using in the navigation problems. So this is distance is equals to d long cos parallel lat. So parallel lat, somewhere we need to use the parallel of latitude, somewhere we are using mid lat, like we have two latitudes are given, so we will use the mid latitude, and somewhere we are using the mean lat. So these all are almost similar, only depending on the question we will use sometimes mid lat, sometimes mean lat, sometimes parallel of lat. But the basic formula you need to remember that departure equals to d long cos mid lat and departure equals to d long cos mean lat. And distance is equals to d long cos parallel lat. These are three formulas. Then again we have other formulas, that is departure upon d lat equals to tan cos, and departure equals to distance sine cos, and d lat is equals to distance cos cos. These are two meridians. This is parallel of latitude, and this is suppose point A, this is point B, and this is the effective distance. Sorry, this is the distance, and this is the departure. Okay. This is departure, this is distance. We will make one right angle triangle like this. So as we know, this is distance. This will be d lat, 1 lat, 2 lat, so this will be d lat, and this is departure, and this is the force. Okay, so as we know from the trigonometry that this is base, this is hypotenuse, and this is perpendicular. So sine is equals to perpendicular upon hypotenuse. So sine theta is perpendicular upon hypotenuse. So here we will take sine cos. Sine cos is equals to perpendicular is departure upon distance. Distance is hypotenuse, departure is perpendicular. So it will be departure is equals to distance sine cos. So this is one formula which we can verify from here. Here it is, this is distance sine cos. The other one we will see, that is cos theta is equals to base upon hypotenuse. So here cos is equals to base is what? D lat, and hypotenuse is distance. So we can make out from here, this is d lat is equals to distance cos cos. This is second formula. So this is, you can say this is first equation, this is second equation, and by dividing equation 1 divide by equation 2 will be, equation 1 is what? Departure is equals to distance sine cos divided by d lat is equals to distance cos cos. So it will come out departure upon d lat is equals to distance upon distance into sine cos upon cos cos. So distance cancel. It will be departure upon d lat is equals to sine by cos. We know this is tan theta or tan cos. So departure upon d lat will be equals to tan cos. So this is the third formula we have verified. So here, okay, all three formulas we verified. So now we will see one question based on force and distance. So what this question is saying, that position A is 21 degrees 06 minutes south and longitude is 135 degrees 08 minutes west. Position B is 26 degrees 51 minutes south, 132 degrees 45 minutes west. Find force and distance from A to B. So for that we need to first draw the diagram, because once you will draw the diagram, half of the problem is solved. So first we'll draw one position. Suppose this is position A. What it is 21 degrees 06 minutes south and longitude is 135 degrees 08 minutes west. Now we have to see the second position where it will lie. So it is 26 degrees south. So it will be south of A, because latitude of A was 21 degrees south and this is 26 degrees south. So it will be definitely south of A. Okay. Secondly, it is 132 degrees west. So it is definitely east of A, because suppose this is prime meridian. So 135 degrees west is here. 135 degrees west. So 132 degrees west will be somewhere here. Okay. So we come to know that this point is lying somewhere here. So this is B, that is 26 degrees 51 minutes south and 132 degrees 45 minutes west. We will join these two. Okay, we have joined these two. So this is the distance, and what will be the course? The course will be this much. This is the course. So course is something we are measuring from, always from north, from here to here. This is the course. So to identify the course, first we need to make out d lat. So that will come 26 degrees 51 minutes south minus 21 degrees 06 minutes south. So it will come out to be 5 degrees 45 minutes south. You do your own calculations. This is just for your reference. Then we will calculate d long. D long is equals to 135 degrees 08 minutes west minus 132 degrees 45 minutes west but we are moving in direction east, so it will be east. How much? It will be 2 degrees 23 minutes east. Now dlat and dlong are identified. Now we will calculate mean let. As I told you earlier that in some questions we will calculate mean let, mid let. So mean let is equals to, how we will calculate mean let? So as we are calculating the average, we will calculate the mean let. So it is 26 degrees 51 minutes south plus 21 degrees 06 minutes south divided by 2. So this will come out to be 23 degrees 58.5 minutes south. So we identified the mean let. Now next step is we need to find out departure. Departure equals to d long cos mean let. So d long, we know d long is how much? D long is 2 degrees 23 minutes. So this we will have to convert to miles. So 2 degrees is 2 multiplied by 60 plus 23. So it will be 120 plus 23, which will be equals to 143 minutes or 143 miles. 143 we will enter here, because departure we will calculate in miles. 143, and cos mean let we know 23 degrees 58.5 minutes, and departure will come out to be 130.662 minutes or miles. After that, we will apply formula departure upon dlet is equals to 10 course. So departure is 130.662 divided by dlet is 345. So that also we will again convert this dlet we will again convert to the miles. So it will be 345 miles. So this will be equals to 10 course. So course we can find out. Course is equals to 10 inverse of 130.662 divided by 345. So course will come south 20.7 degrees east, which we will write in 3 points. That will be 159.3 degrees. This will be the true course. Okay, this is the way you have to write the course in 3-point notation. After that, we need to find out the distance. So dlet is equals to distance cos course. Dlet we know dlet is 345. Distance we need to find out, and cos of course we know. Here we will use the quadrant form of course. That will be 20.7 degrees. So distance will come 368.9 miles. Okay, this way we will find out distance and course for this problem. Okay, this is course and this is course, this is distance. So once you will draw the diagram, then it will be very easy for you to find out everything, and you have to remember the formulas. That's it. So in this video we have seen the definitions of latitude, longitude, dlet, dlong, departure, and we have also solved one example. We have seen the formulas, and in the further videos we will solve the questions related to latitude, longitude, departure, dlet, dlong, and we will proceed further to celestial navigation also in the upcoming videos. Thank you very much for watching. Stay tuned.